Hello, everybody. So today we are looking at October-November 2025, a level 9709/11, paper 1, pure maths paper 1, and you'll need your MF19, of course. So I'm going to start at number 1 directly. Now, uh, this is a question that requires you to remember the concepts of discriminants. It reads, find the set of values of the constant k for which the quadratic equation has two distinct real roots. Sorry for that. You can see you only have these three case scenarios. The first case scenario is where you don't have a root at all. And in this situation, the line or the graph will never get to the x-axis. In this situation, you only have one repeated root, and over here now finally you can have two coordinates, meaning you can have two distinct roots because you can see those two values are not the same. Now, this question is a very straightforward question. It's one of those whereby you should easily get the 4 marks. Now, you can see the equation given to you already is in the format or is in the form of a quadratic equation by itself. See, you need to remember the basics of a quadratic equation. Now, these are the basics. We usually say that we have what we call the general form of the quadratic equation, which is ax squared plus bx plus c is equals to 0. Sorry. Now, you need to understand what A, B, and C mean as coefficients as well as constants. So, if I was to compare these two equations, my A here is going to be equal to 3k because that is the thing before x squared. My B here is going to be equal to k plus 8. Then lastly, my C is going to be equal to positive 3. You really have to be careful and don't make a mistake when you're picking up the signs. Don't miss a negative if a negative was available. Now, you have to use these values and connect them with the concept of two distinct roots. So we're going to have to use this concept over here. B squared minus 4ac is greater than 0 because that's the only time you'll have two distinct roots. So b squared minus 4ac is greater than 0. So that's the first thing you're going to put down. B squared minus 4ac is greater than 0. They said this is what we call the discriminant. Discriminant. Such a long word. Now, what is your b? K plus 8. Substitute for it here. Square that. Minus, you have 4 into, your value for a is 3k. Your value for c is positive 3. Everybody here has to be greater than 0. Sorry for that. Now, this is a quadratic expansion, and if you expand that, you're going to end up with k squared plus, that will be 2ab, so 2 times 8, that will be 16k, then plus 8 squared, that will be 64, then minus 4 times 3 times 3, 4 times 3 times 3, that will give you 36, so this is minus 36 is greater than 0. Now you can see, you just need to try simplify this question now going ahead. These two guys are like terms, so you can, oopsie, I forgot a k somewhere. This guy here must carry a k because there was a k there, sorry for that. So this is 36k. So this 16k and the 36k minus, this is positive and this is minus. They will simplify to give you minus 20k plus 64 is greater than 0. My handwriting, my kindergarten teacher was bad. Now you can see, again, this is a quadratic equation which can be solved And I always advise people at this level, like the best way to go for this is the quadratic formula. It saves you a lot of time. Try your best to be conversant quadratic formula with the quadratic formula. I have another video on the channel. I'll attach the link down there on how to use it. If you have a problem, please go watch it. But the quadratic formula, because now I'm dealing with k, reads k will be equal to minus b plus or minus the square root of b squared minus 4ac, all these all over 2a. This is a formula that you can easily cram and remember. Now I'm trying to solve for this equation. You can see here my a here is equals to 1, my b is equals to negative 20. I am very case specific, and my c is equals to positive 64. So let me see what k can yield. So minus b, this will be the minus of minus 20, then plus or minus the root of b squared will be minus 20 squared minus 4 times my a is 1 times 64 all the way. So the whole of these will be all over 2 into 1. Now, you can easily simplify this question really quick. So k will be equal to positive 20 because negative times negative gives you positive. This will be plus or minus the square root of 20 negative squared. Negative 20 times negative 20 will yield positive 400 because negative times negative becomes positive. Then minus 4 times 1 is 4. Then times 64, you'll get 256. Please cross check from your calculator. Everybody here all over 2. So k here is going to be equal to 20 plus or minus the square root of 400 minus 256, I believe, is 144. Now, if you divide everybody here by 2 again, you're going to have k is equals to 20 plus or minus. The square root of 144 is 12 over 2. For me, I'm going step by step. If you want to forward the video, you can forward it further to see the last concepts, but I'm just going step by step to show everybody how you can get the value of k. So k can either be 20 plus 12 over 2, or k can either be 20 minus 12 over 2. So from this case scenario here, 20 plus 12, this is going to be equal to 32 over 2, and this is going to be equal to 16. And from this case scenario here, this is going to be equal to 8 over 2, which is equals to 4. Now you can see k can take those two values. K can either be 4 or k can either be 16. But now there's an issue here. You have to go back and remember what the equation said originally here. It's told you this is greater than 0. So for you to be able to see the correct connotation of the inequalities, the best way everybody always advises everybody is to sketch the graph, be able to see the graph. So this point, call that 4, this point, call it 16. Now remember, we are being told that we have to have a situation whereby we're greater than 0. So we have to ask ourselves, which part is greater than 0? This part is the part that is greater than 0. On this line, we are equal to 0. Here, y is equal to 0. Down here, we are less than 0 because we are dealing with negative numbers. Now, we need to have a situation to read the values, a set of values for k, such that this set of values will always have a case scenario whereby they will always be greater than 0. So you can see it's only this chunk that exists greater than 0, and only this chunk exists greater than 0. So you can see from here, k has to be greater than 16. That's the only way you can be able to read all these values. And from here you can see k has to be less than 4. So these two values become your answer, because you're being told find the set of values. And when they talk about a set of values, it means it's not just one value, it's a set of values. So any value that is less than 4 will solve your problem, and any value that is less than, I mean greater than 16 rather, will solve your value, will solve the question. The issue is anybody between 4 to 16, 4, 5, 6, 7, no, not 4, 5, 6, 7, all the way to 15. Anybody between 5 to 15 becomes not a set of, it becomes a value or a set of values that cannot satisfy this equation. So see you in the next video when you solve for number 2.